go on a tour through the universe, but we're going to start off small. We're going to start off where we are, and we're going to look at the night sky. Here in Namibia, of course, or in Venture, let me put it like that. Remove this, there's no clouds. Okay, so this is currently in Venture, Namibia. You can see our mountains. They are very white for keepers. There's no internet connection. That's why they look like this. But they're supposed to be brown. And this is the current spot of where the sun is. Right? The sun is currently just about to set.
Right now.
Right now. So the time in the dome is 17:21. I think that's the right time, right?
Yeah.
Okay. So of course I can play around with time, and I can make the night set. Yeah, this is the Namibian night sky. If we were to remove all of the lights during the night, we would all be able to see this. But due to light pollution, we cannot see it. We cannot see it like this. As clear as this. So the first thing that you will obviously see is this patch. This is the Milky Way Galaxy, but we are also within the Milky Way Galaxy. But this is when you're actually looking towards the galactic plane, and then you see. Please,
Leo.
take pictures as much as you want, but just put on the flash. Yeah. Okay, so we also have this. These two patches that you see here, you can actually see this with your own eyes, and these are actually dwarf galaxies outside of our own galaxy. They're actually gravitationally bound to our own galaxy. And this is the large Magellanic Cloud, the small Magellanic Cloud, dwarf galaxies. And you should be able to see this with your own eyes actually, if you are in a dark place. Like for me, I'm from the northern side. If I'm at my residence in the northern, at the village, I can always see this, like with my own eyes. Right? Stars with different colors. Okay, this is the light. Stars with different colors. Some are actually yellow like that, some are actually white. So we as humans, we tend to associate blue things with cool and red stuff with hot. But in nature, it's not like that. It's the other way around.
Oh.
So the blue stuff are very hot. The blue and white stuff are very hot. The yellow and red stuff are very cool. In this case, these stars that are blue are very, very hot. The ones that are actually yellow are a bit cooler.
Why is the sun yellow then? Is it not hot?
It's not hot. It's hot, but not hotter than the other stars.
Really?
In comparison, like the blue ones, in terms of temperature. So an example of this, is if you have a gas stove at home or something, right? And let's say you are in a hurry, you want to heat food quite fast. You switch to maximum intensity.
Yeah.
What would the flames be of
Blue.
the color? Would be blue.
Yes.
That means it's very, very hot.
Yeah.
You know, if you reduce that, it will be a bit yellow, kind of like that. So that's something in nature. Another example is a blowtorch that you use to cut steel. You need something very, very hot to cut steel, and it's always blue, right? Blue whitish. So stay away from the blue stuff. I always say that. Yeah, very hot. Okay, now we'll actually try and just see what is this. So, like I said, this is the Milky Way Galaxy. You have some black stuff that you see there, and this black stuff actually gas and dust in space. The white stuff that you see there, they are all stars. But these stars are actually a lot, and they are so compact together that your eyes cannot make out the individual stars. That's why you only see like one continuous white thing there, and that's where the thing comes from. It looks like spilled milk. That's where the word Milky Way comes from. Right? But then we as astronomers, we use different energies to see different energies in the night sky. A type of energy that is locally used here that you will be familiar with is X-rays. So an X-ray is a type of energy that people use to see in your body, but they don't need to cut you open.
Yeah.
So the wavelength will go in your body, but it will penetrate via your tissue and they can actually see what's in your body. So we can use different other energies also, such as gamma rays, X-rays, radio waves, or those are also types of energies. So if I switch on infrared, we can actually see beyond the dust and gas. And this is what we see. We see that there's actually a lot of stars in the galactic plane. So One thing that my colleague did not mention outside there is that we already have massive telescopes here, world-class telescopes here in Namibia, located at the Hess site, about 120 kilometers away from Bethel. This is a world-leading observatory, right? And they observe gamma rays. So that's the type of energy they actually observe. And if I switch on,
What are the gamma rays do?
it's just a type of energy
Oh, okay.
that is used. In this case, the telescopes actually pick up the gamma rays, that specific energy, and then they use it to image the sky. And this is basically what they could see, right? So they see that there's a lot of violent activity happening. So gamma rays are basically emitted by very energetic events, like a star dying and exploding, going supernova, and it gives off those high energies, right? And as you can see, because there's a lot of stars, what's the galactic plane, there's a lot of gamma rays being emitted from there. A lot of stars dying. Right. Okay, so now what we will actually move and try and see the constellations that we find. So the question is, what are constellations? So constellations are basically groups of stars that form a specific pattern, right? And the Greeks came up with these constellations, and we have about 88 of them.
We can see them in Namibia.
These are the ones that you can only see in the southern hemisphere.
I can
So if
tell
you
you,
go to the northern hemisphere,
I can tell you
some of
these
these you can't see them, right?
These are in Okwalubi. I can tell you that.
So now since you called Leo, I always imagine the Greeks, one guy is outside during the night eating these mushrooms that make you high and looking to the night sky and saw that and say, that looks like a lion. So I call it Leo. So Leo is a lion, right? So they then says, that looks like a lion. Does that look like a lion, guys?
No.
That guy was probably high, right?
I think the guy is high.
You are high.
Yeah, but anyways, since Leo says when you are high, it looks like that. We are also gonna get high for some time, a bit. And we're gonna see what they actually saw. We're gonna get high. So this is actually what they saw, right?
What?
So the Greeks looked at this and they saw the lion there. They say the scorpion here.
Yeah, the scorpion. Yeah.
Scorpion. They saw the famous Southern Cross, which is very famous here in Namibia because it's always up throughout the whole year.
Yeah.
And then there is one famous constellation, and this is the Orion constellation just behind you, the Hunter. Exactly, someone said the Hunter, right? So have you ever asked yourself what Orion was hunting for? They say Orion the Hunter, right? Taurus. No, it was something much smaller. Look at this foot. No, you're almost right. Look at this foot.
Eridamus?
No, at his foot.
Oh.
Leopards, a rabbit.
Oh.
So Orion was hunting for a rabbit, leopards, right? But the question is, what was Orion hunting with? If you go hunting for a rabbit, what would you take along? What? For a rabbit? They are quite fast, eh?
A torch.
Something that is very fast, right? That they need to run after it.
The
A dog, right? Can you see the dog? Can you spatial? There's a dog, right?
No, it's wait.
I see him.
Where is it behind?
That's the dog. So Orion went hunting for a rabbit with this dog, right?
Are these cool? Are these real stuff?
Go outside today,
Yeah.
in a really, really dark place.
Yeah. Yeah.
It's a bad place. You can see a lot of light. You will see the sky like this. At 1922, the sky will look like this.
Really?
All of these stars will be there. 1922. If it's very dark, 1922 today, and you go outside and you can identify this. If you can identify those three stars. By the way, Orion is where we have the oldest star that we know of. In the nearest oldest star that we know of that is dying. It's called Betelgeuse. It's very, very big, and it's about to go supernova. It's about to explode.
So what happens when they explode? Do we see them here on Earth?
Then you see.
Do they
You
land?
will see something bright in the sky.
When I was young, something actually landed in my eyes.
No. Stars are
Does it
different.
become
It's
a
not that. It will not
meteorite?
reach us, but
Okay.
the energy will reach us. That's the energy we see, we pick up.
Then what happened to the meteorite?
We'll come to the meteorite.
Thank you.
Meteorite.
So,
Okay.
so long.
Yeah. So now I think it's time for us to go into space and fly off and lift off. And now we're gonna look back on the Earth and we're gonna pinpoint our location. And before we even pinpoint our location, some people say no, the Earth is flat.
Guys, this is
and so forth,
amazing.
right?
Oh my god!
Yes.
Is Antares part of the stars?
Yes, Antares is part of the stars. We already went by. You would have seen the brightest
Tell us a bit
star.
about Antares.
Not much I can tell you, right? Because we don't
feels
have
so
it
real.
in our, so we cannot visit it. Yeah.
Guys, I can see my
Okay.
village.
Yeah. So yes, so this is the Earth from space. We are in space now, and we are looking back. So some people say, yeah, the Earth is flat.
There comes Africa.
If I move it like this, you can see there's a place where there's darkness, where darkness starts. This phenomena will not happen if the Earth was flat. This phenomena where some people are living in the night, some people are living in the day, will not happen, right?
Science is so tricky. Are you sure that we are not moving?
Okay, now we will quickly move to Africa. Here we are. It's just a bed turned upside down, I guess. Okay, there we are. And I'll zoom in quickly, and I'll give you 3 reasons why in Namibia we have one of the best night skies to do astronomy. In fact, we are top 3, and I'll argue that we are top 2 with Chile. Namibia is Africa East. And the area where you see a lot of lights, that's the Gauteng province. Johannesburg, Pretoria, there's a lot of people, there's a lot of light. If you look at Namibian area this side, during the day, we went to the night. Remember, we started off in the night. We are in the night. The time is still 17. Sorry, the time is now 5 a.m. in the morning. That's why you see the light is about to come over.
Yeah.
Right? The light is about to come over Namibia because it's 5 a.m.
So ESCOM is the oldest one.
Yeah, they are keeping them on
Everyone else
during this day. Yeah. So we astronomers, we don't like light. So when things are dark, you see the stars better. That's why I say if you're in Ventum, you will not see the stars better. So there's a term we say light pollution. And if you look over Namibia, we have less light pollution. You look over in South Africa, quite a lot of light pollution. So if you want to do astronomy, you rather pick Namibia.
Yes.
So that's the place you want. So that's reason number 1. So reason number 2 is if I light up this. So if you head over towards the equator, you know, Angola from Namibian area, you see it's starting to become green and there's a lot of clouds.
Yes.
And you see Namibia is quite brown. So what it means is that we don't have a lot of rain, meaning we don't have a lot of clouds. So over 90% of the days in a year in Namibia, we have cloudless nights. So if you randomly take your telescope during any specific day in a year, you point it to the night sky, you are likely over 90% to see no clouds. So that's what it's telling us. So that tells us that there is nothing to block your view to study whatever you want to study out there. And that's reason number two. For reason number 3, it's what I am actually doing for my PhD. So we are doing site testing for the telescope we want to build.
what?
PhD,
Okay.
permanent head damage.
Nice one. Say that again, please continue. It's what?
Yeah.
Reason number 3?
Yeah, coming in.
Continue with reason number 3.
Yeah, so reason number 3 is that you see, since we don't have a lot of clouds in Namibia, it means that we don't have a lot of water from the clouds in the atmosphere. Now, at the energies we are observing, we need less water in the atmosphere because those energies are actually absorbed by the water in the atmosphere, or they get scattered, or they pass us through, but then the signal gets delayed, which makes it difficult. Remember, this telescope will not work alone. What my colleague did not mention outside is that this telescope will be part of a network of telescopes all over the world. We have one at the South Pole, some few in Chile because it's also good, some in Northern America, some in Europe, and they are working together. And of course, we needed one in Africa. Now imagine that they observe at the same time, looking at the same source, maybe a black hole, and at the other sides we don't have water in the atmosphere, so meaning the signal just goes through, not hindered. And at one antenna, the signal gets hindered by the water in the atmosphere but passes through, but there's a delay. Now you have to compensate for that delay in the when you are imaging your image for the source, which is quite bad. So we want less water in the atmosphere for that regard. And that's why Namibia was specifically chosen. If you look over Africa, the only dry places that you can see there is actually Namibia, Botswana, but we needed a place on the western side of the continent to connect with the other telescopes. You see the other telescopes in Chile, if I do this and I move in straight lines, if I move over, so somewhere Namibia is here, and I move in straight lines like this, you'll see that then I move like this in straight lines, you'll see that Chile is somewhere here, right? So we needed to connect our antennas there like this, right? And some in Europe. So we needed something, and the only place was Namibia. So we just
On
had
the
to figure
western
out,
side,
which place is better within Namibia. There's two sites, and I'll quickly come there and show you the two sites.
So what are they looking at in the space station? Outside of the moon. What are they looking at?
That's the Chinese tracking system, tracking agency. They track their own satellites.
Oh, they said that.
When they come into our hemisphere, then they take over and they track and they receive data. Yeah, they have their own satellites. So Chinese have their own satellites revolving around the Earth, and then when it comes into our hemisphere, in our region, then they also track the satellite from the Earth. Remember, China is the other side of the continent. So the satellites move all over, right? So when they come in this region, then they observe now, they get the data. We don't have, Namibia simply don't have satellites.
Lot, can you explain the black hole?
Yeah, I'm not moving there because of people keep asking questions. But first, let me
But what
hurry
is
up
a black hole? If you can just
and
define
do
it.
this. So I'll put a thing there label, and that's where we are. And where do we want to build the telescope? We want to, first option is Grossman Mountain, and the other option is the hair site. So these sites are actually separated by 30 kilometers, and the hair site is about 120 kilometers from Vento. Okay, now that we have seen that, someone was asking about meteorites. So if I zoom in, sorry for that, I wanted you to see something, and for some reason you can't see it. Okay, there it comes. You see this invisible line around the Earth?
Yeah.
So this is the atmosphere. And the atmosphere, that's where, from beyond that is space. Inside there, you're still within, you can still breathe. Beyond that, you cannot breathe, there's no oxygen. But it also has other uses. And the other uses is that it protects us against meteorites. So like asteroids, when a rock enters from space, it starts to burn up due to friction in the atmosphere. Now if...
Oh wow.
Yeah, that's when you guys go shooting star, eh?
Yeah.
Because that's the rock burning up in the atmosphere. And that's why it only comes and then it goes, it's done.
Yeah.
There's no luck there.
There's no star, there's nothing. But if we move to our nearest neighbor, which is the moon, it has no atmosphere. So what actually happens when a body has no atmosphere, right? If there's a rock or something in space on a collision path. So this is basically what happens. So if you have a rock in space on a collision path with the moon, because there is no atmosphere to cushion it, it will just move straight on, passes through. Yeah, and it impacts it, and the crater will be left behind. So all the materials will be injected into space because the moon has a weak gravitational force. And that's how all of the craters that you see on the moon are formed. So it's like the moon has an abusive relationship with the universe.
What?
Abusive relationship with the universe.
Yes.
Yeah, it keeps being slept, right? Like,
Yeah.
you know. But that's how all of those form. Now with this, I will quickly move to the sun, and let's give it time, and then we'll give a quick description of the sun and the solar system. We choose one planet and we start zooming out of the galaxy, so we see the galaxy better.
This is so amazing.
Okay, so this is the sun.
Are we using Jupiter or Pluto?
We can choose whatever planet you want.
Okay.
So this is the sun. On the surface temperature, it's about 6,000 degrees Celsius. those black spots that you see, they are called sunspots. They are about 4,000 degrees Celsius, and they are caused by the twisting of magnetic field lines from the sun. So just like the Earth, the sun also has magnetic field lines, and sometimes they twist and they form these black spots at the position where the twisting happens.
The sun rays.
So in the core, the surface temperature can get to 15 million degrees Celsius.
Yo?
15 million.
Yes.
Can you survive this?
No.
No, you're gone.
How?
Anyway, so Mercury is the innermost planet, and for people that likes birthdays, every 88 Earth days, you have a birthday if you are living on Mercury.
Ay?
So, yes, it takes 88 days to revolve around the sun. But again, if you like birthdays and you are living on Neptune, so every 167 Earth years, then you have a birthday, which is not possible.
Yeah.
Zero, you will be kaput without a birthday.
Yes.
Right.
So Neptune is not our favorite. Jupiter?
Yeah. So if I quickly do this, you can see that the solar system is actually flat from one direction. So our sun is a second generation star, meaning that there was already a star before this one. If you remember your periodic table from school, high school, hydrogen and helium are basically the first two elements, right?
So it's sun.
Now, our sun is made out of hydrogen and helium. That's what it burns in the core. It burns hydrogen. It fuses them together to form atomic number of 2, which is helium. And that's how the heavier elements are born, right? But it only has hydrogen and helium. So you should ask yourself, how did the iron in your body form, in your blood, calcium in your bones form? It's because there was already a star there, and it exploded, went supernovae, and it threw out elements in a specific direction. And for example, this was a direction like this. So all of the materials were thrown out in this direction, so they started rotating in that direction. So that's why all the planets are rotating like in a kind of a flat direction. That's why you only see a line. But now if you put the orbit of Pluto on, because when I was in school, Pluto was a planet. We had 9. But if you put the orbit of Pluto in, it's having this weird orbit. So because of this, we say, okay, Pluto was not formed at the same time as the solar system. It was probably formed it's just a rock on the outer skirt, came too close to the gravity of the sun, and got captured and kept in orbit around the sun. And we think that's why it's actually, we consider it first as a planet. Until now, Pluto has not completed any orbit around the sun. It has not completed its orbit, just like one. It has not done that yet.
Ever.
And it's quite smaller than the moon. That's reason number 2. So it's now classified as a dwarf planet. Now we can choose one planet. One planet.
Before we go to the planet, you said the sun is the second star. The first one went supernova. So the probability of this sun going supernova?
So this sun is still halfway through its life. So there's still something like 18 billion. So
Before it explodes on. Then what comes after the sun now? What is the third generational star? What is it?
Depending on the mass of the sun, there's always ways that it can go. It can either become a neutron star, black hole, or just a dwarf. It dies off. The energy it gives off, and there's nothing else.
So the Earth will be black.
So we'll come to the black hole. Let's quickly just rush. One more planet, please.
Jupiter?
Jupiter, okay.
Yeah.
Well, this is the biggest planet. So it's about money, right?
Yeah.
So if you wanna become so rich,
Wealthy.
go to Jupiter. It rains diamonds on Jupiter.
What?
What?
It rains diamonds on Jupiter.
We receive.
And you see why people are actually investing a lot of money into space. Elon Musk, Jeff Bezos, because they want to exploit. They want to find a way to exploit. Because the rich is actually out.
Is it the chemical elements?
Yes. So the atmosphere is made out of, there's a lot of carbon monoxide, and there's a lot of stress and pressure. And diamonds form around these conditions, and occasionally you will have diamonds raining there.
Wow.
Yeah.
Pick them up. You're not even
And
mining.
the sun and Jupiter almost also became a star. Only needed 2% of hydrogen and helium to become a star.
2%.
So we would have had two stars. The other thing is, so Jupiter is four original moons, And these moons are actually Io, Europa, Castile, and Ganymede. They were named by the great Galileo, the one that observed them first. But it has additional moons. Just like the sun pulled in Pluto, the moon also pulls in rocks around it. And if we add the other rocks around it, this is what we'll get. So the moon has other additional moons, and these are all other moons of Jupiter, sorry. Right? So all of these are moons. So I have lost count. I no longer keep on track with it. Right? The other thing is on Jupiter quickly is that we have this eye. Let's see if I can really get it. Let's see. How do I move? Where is that eye? I was actually seeing it. Where is this eye? Okay, maybe I made it wrong.
Wrong end.
Yeah, maybe I should look like this. Should be somewhere here. Oh, there it
We
is.
believe in miracles.
There it is.
Yeah.
You see this eye?
Yes.
If I actually, this thing is actually bigger than the Earth, the size of the Earth, and this storm is actually bigger than the size of the Earth, and it has always been there. And if I put a copy of the Earth, you see the Earth here, right? And look at the eye. That thing is bigger than the size of the Earth. And that's a storm.
A storm.
Jupiter, yes.
Storm.
Storm. Storm.
A storm. Storm.
Yeah.
A diamond stone.
Yes.
Storm like whatever.
Now we will quickly zoom.
Whatever
Quickly
triangle.
go to the sun again, and now we start zooming out. Now we have to imagine we have a spacecraft, this spacecraft, and we can move big distances in small time,
Where have
right?
you been?
We say that I'll put a label on the sun. The reason why is because if you are living among stars and you are so far away from home, you want to find your way back home, and you are looking for the Earth, you will not see it. You will have to look at the sun. You will have to identify where the sun is because it gives off energy. Then you know that that's where the Earth is, somewhere in that region.
Okay.
So now I will start zooming out, and we're gonna move away from our home, the Earth, and we're gonna zoom out. We're gonna move vast distances out of our galaxy. So, by the way, this is all real data, not simulated data.
Yeah.
Picture, right? All of these are stars, by the way.
So it's not
Within our own
science.
galaxy.
Okay.
Stars within our own galaxy. We move out, we zoom out, we zoom out, we zoom out. We are out of our galaxy, right? This is the Milky Way Galaxy.
Oh.
But this image is because you cannot image your own. That's where you are. It's quite difficult to get out of our own galaxy and image this. So we looked at other galaxies, and we know that our galaxy is a spiral galaxy, and we say it probably look like this. But we do know our position of the sun in relation to the center, right? So we do know our position. So our galaxy is a spiral galaxy, and if I quickly do this and spin it, you will also see the two dwarf galaxies that were here. There they are, 1 and 2.
Oh.
Right? So the sun moves at a speed of 230 kilometers per second. From here to Okahanja in 1 second.
Yeah.
Sorry, no, Ochivarongo in 1 second. From here to Ochivarongo in 1 second, right? But the sun still takes 230 to 250 million years to just make one orbit within the galaxy. Just to revolve, to come back in that same existence. In the center of the galaxy, we have a bulge, and that's where we have the black hole. The areas where it's actually shining, that's where we have stars being born, so star formation regions. The galaxy across is about 27,000 light years across. What it means is that we all know that light is the fastest thing that we know of the universe. It moves at a speed of 300,000 kilometers per second. But yet it takes 27,000 years to just cross, to move from one point to another, just to move from that. That's how big it is. Now we will quickly dive deep into the center of our galaxy. Someone was talking about the black hole.
Thank you.
Yes, let's go there.
Okay.
Actually, that's where you can alter.
Oh, this is so beautiful.
Yeah, so that's where time comes to a standstill because the gravitational pull is so strong.
Yes, yeah.
So remember that the faster you move, the faster time goes to zero. Just think of it. If you are moving, let's say you are driving from Bentu to Okahanja and you are driving slow, then that means your time becomes longer, right? The more faster you move, the more you reduce time. So now at this point, the gravitational pull is so strong, and gravitational pull is just acceleration. So the acceleration is so strong. So at that point, the time approaches zero. So t becomes zero. If let's say you can survive in there, when we throw you in there, you'll be alive. You'll be alive, you know, forever. Yeah, because time will be zero for you. I mean, unless you die of hunger, of course. But of course, the black hole will tear you apart before you even reach there. So. But anyway, so before those images that you saw there, we did not have any picture of a black hole, any. So this was an artistic impression of a black hole. This was done before those images. So physicists came up with equations, they plugged them into a supercomputer, and they said, this is how a black hole should look like in 3 dimensions, right? This is 3D. So this is how it should look like. And in 2017, they pointed their telescopes to the center of our galaxy and to the center of another galaxy called M87. Then they released the first image in 2019 of M87 because it was much easier to image than this one. And the results look something like this, at least this what we have here. It's just that this is 3 dimension, that is 2D. Now the idea is that we put a telescope here in Namibia, we start creating movies. We get proper images and proper videos, like 3D. How does it move, you know? Yeah, so what is a black hole? So someone asked me.
Yes, what is a black hole?
Okay, we are inside hole. Anyway, a black hole is just a point in space where you have a lot of mass concentrated in that space such that the gravitational force is so strong. So in that specific region, so for example, this black hole is smaller in size than our sun. In size, smaller than our sun. But the mass is about 4.2 million solar masses. So you take the sun's mass, you multiply it by 4.2 million. That's when you get the mass of this thing. But it's smaller in size. Right? This one is called Sagittarius A star. Because you find it in the Sagittarius constellation. Those constellations that we saw there. You have to point in that direction to see. Okay, now we zoom out. Now we say if you live among galaxies, no longer stars, let's say we can fly in between galaxies, and we now zoom out.
Sorry, before you go ahead, the black hole, does it also rotate along with the galaxy? Does it also move?
It's actually in the center. The black hole does not move, but the matter moves around it because of the gravity.
And is this the reason why some planes disappear?
Somewhat?
Planes, airplanes, aircraft.
No, it's so far away. So the planes will never reach there. Whatever
So
you
why
send
is
there
it
will
that-
not reach there. It's so far.
But why is it that we have planes that disappear?
And
No,
especially in
these
the
are
Bermuda Triangle.
Yes, this is on Earth. Don't worry.
Yeah,
That's still within local. This we are talking about big distances.
exactly. The
Vast.
the triangle. Bermuda Triangle.
But they still call it the black hole.
Now, okay, we'll ask the questions at the end because we're almost at the end of the show. So these are all galaxies, and this is the real data taken with the Hubble Space Telescope. Just like ours, Milky Way is just a galaxy among other galaxies.
And I will show our
And
galaxies
each
only.
galaxy can have about 40 billion stars. Right? 40 billion stars. Even within ours, 40 billion stars, and each galaxy can carry 40 billion stars. Right? Now we start zooming out. Remember, guys, we only know 5% of our universe. And we zoom out, we add more galaxies. Real data. Each dot that you see there is a galaxy. Right? Each dot you see is a galaxy like ours, just like ours. Right? Again, we add more. Another dot again. So each dot that you see there is like ours. And all of this data was taken with either Hubble Space Telescope or with the radio telescopes that we want to build. Right? And you see there, the Milky Way appears to be in the center. But the Milky Way is not in the center. It's because we are observing from there. Think about it, if you are driving your car, and there's a car behind you, a car in front of you, you feel like you're in the center. But the person in front of you, if there's a car in front of them, they feel like in the center because they are looking on from there. Right? So we are no more different than any other dot that you see there. Right? And it looks like a butterfly, Because the reason is because we have a blind spot due to our position within our own galaxy.
Yeah.
We cannot
Yes.
see in those areas, in
It's
those
about
regions.
positioning.
Yeah. Okay. Yeah, I think now we will end our talk here and we can entertain questions outside.